Good afternoon, ladies and gents. Well, today we are going to spend a little time on binomial expansion, and we're going to look at distribution. What is distribution? Well, we know it from algebra. If we have a bracket and there's a little square to it, that means that we've got to rewrite this bracket twice. So x plus a, and then we will multiply each value in the first bracket with each value in the second bracket and simplify that, and that will give us our answer. And that will give us x times x is x squared, x times a would give us positive ax, a times x would give us ax, and a times a would give us a squared. We can simplify that to x squared plus 2ax plus a squared. And that was pretty easy. We've done that for quite a few years in our algebra studies. Now, if we have something with an x to the third power, well, that we've already done the square, so that will mean that I have this thing that we've already found, x squared. So x squared plus 2ax plus a squared, multiply that again with x plus a. And as you can see, this expansion becomes a little bit more cumbersome, but still, it's not too bad. We can do it. And x squared times x would give us x cubed. X squared times a would give us positive ax squared. This one, 2ax times 8 would give us positive 2ax squared. That would give us positive 2a squared x. The last one, plus a squared x plus a to the third power. We can simplify this. I think these terms can be simplified. I gave myself a little too little space, but let's try. Plus x squared a plus 2a. Oh, we can do that as 3a. Plus these two would give us 3a squared x plus a cubed. And we can see that we can simplify this to something. But what about expansion to the fifth power? That will really take a lot of time. We will have to use this x squared, x cubed times the one that we found here. And that will give us quite a large number, quite a lot of expansions to do. So over the years, the mathematicians have came up with a wonderful device how to find this coefficient. So because we know that it will have a leading term of x to the fifth power, and then some terms here in the middle that will end up with a to the fifth power. And these middle terms will be something like, it will be some coefficient with x to the fourth power a, and then plus some coefficient x to the third power a squared, and so forth until we found the last number. But what is this coefficient? What is those coefficients that need to be multiplied to the term in front of the term? Okay, we know our leading term will be 1 because it is just 1. The exponent value would be 1 there. But what if it was 2? If it was 2x and we have to multiply that with 5, what would it have become? And that's why binomial expansion came in, and it's really awesome. So Pascal's triangle is a very old. Pascal lived a couple of 100 years ago. He found that if he created this triangle, he started off with 1 and then 2 ones there. If I add the 2 ones, I get 2. I add another 1 on both sides. That would give me 3, and 2 plus 1 would give me 3, and I add another 1. That would give me 4. That would give me 6, 4. I add another 1, and you can go on with this. that these values would be 14641 would be the coefficient that I have to multiply with each of those terms to find the term here in my expansion. What would be those coefficients that I have to multiply with? Okay, so I've done up to the fourth expansion. Let's do the fifth expansion. That would give me another 1, 5, 10, 10, 5, 1. So if I look at this, this would be my leading term would be 1. So I can now say it would be 1x to the fifth power. Then the coefficient there for the next term would be 5 times 5x to the fourth power a plus, and plus the leading term, the term there would be 10 times a squared x cubed, and so forth. So those coefficients can be worked out by Pascal's triangle. Well, it can go up to how many distributions you want to, but our calculators also have a little key to help us with that, and that's the NCR key. That's the little key here on my calculator with a division sign. So I will press 5 NCR 0. That would give me 1. That is my first expansion here. If I do that for my second one and I change it to a little 1, that would give me 5. The coefficient would be 5, and so forth. So the coefficient of a 3 would be 10, and that's exactly what we found here. 1, 2, 3. Or 0, 1, 2, 3. So that would give me my coefficient there for that term. Okay, let's see how that works in the practical. I've got a couple of exam questions here that we're going to work through. Okay, in the expansion of 1 over ax plus 2ax squared to the fifth power, the coefficient of x is 5. Find the value of a constant a, and this is worth 4 marks. So we know that the coefficient of x would be 5, and I'm just writing that down. Then we need to take this and expand it to 5. Find the x that can stand on itself. So we'll start with 5 0, 5 1, 5 2, 5 3. I'm just putting the framework down, and 5 5. Okay, let me move it up slightly. You can see there. Then I'm taking this leading term. The leading term will be 1 over ax to the fifth power. The next one would be 1 over ax to the fourth power, and my second term would be 2ax squared. Then 1 over ax cubed, 2ax squared. Wait, I want x. So up to there I've got x in the denominator as to the fifth power. Here I have in the denominator x squared, but all of a sudden here, this would be the expansion that I need. Okay, so I either can use my Pascal's triangle, or I can use my NCR key on my calculator and find what is this expansion. So 5 NCR2 would give me 10. Okay, times, because all of these are times multiplied with one another, and I'm just a cubed x cubed. So you need to use your information from chapter 2 in your textbook, all the exponent rules and index rules to simplify these. 2 to the second power would give me 4. A squared x to the fourth power. Okay, now let's simplify this. That would give me 40. A cubed, a squared, I will, that was a 40, sorry, and that would be a in the denominator. x cubed, x to the fourth power would give me an x in the numerator. Okay, so we know that this thing would be equal to 5x. So I'm setting it equal to 5x. So 40 over ax equals 5x. Now x and x can cancel out, so we will have 40 over a equals 5, and I can solve therefore a would be the value of 8. Okay, how would I gain my marks here? First of all, I will get a B1 mark for recognizing that this is the expansion, okay, that I need to use. Then I will earn another B1 mark for expanding it over there. I will earn a A1 mark for setting these two values equal to one another, and another A1 mark for finding the value of A as 8. Okay, good. Let's go on to the next one. Okay, so this is from a paper, it's May, September, yeah. So it's May, June, paper 2017, question paper 11. This was question 1. So the coefficient of x squared and x cubed in the expansion of 3 minus 2x to the 6 powers are a and b respectively. Find the value of a over b. Good, so we need to do a bit here. Let's do the expansion first. So it would be 6, 0, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Okay, this first one would be 3 to the 6 powers, 3 to the 5th, negative 2x. We are looking at x squared, so it's now the first 2. So 3 to the 4th power, negative 2x squared. That will give me the first one, x squared, the coefficient of x squared that we're looking for. So it would be that one. And 3 cubed, negative 2x cubed. Yeah. Okay, so it would be those two, because x cubed and x squared are the ones that we're looking for. Okay, so let's have a look. I'm just going to rewrite that quickly on another sheet of paper so that I have some more workspace. So we had 6, 2, 3 to the 4th power, negative 2x squared. I'm giving myself a little space to work. 6, 3, 3 cubed, negative 2x cubed. Okay, so what would that be? 6 NCR2. Either use your calculator or use Pascal's triangle. 6 NCR2, that would give us an expansion of 15. So the coefficient would be 15 times 3 to the 4th power. 3 to the power 4 would give us 81 times 81 times negative 2 squared would give us 4, positive 4, because a negative times a negative is a positive, and we will have x squared. Now multiply 15 times 81 times 4, we get quite a large number, 4860 x squared. Okay, now let's do the same thing for the next expansion. So 6 NCR3, that would give us 20 times 3 cubed, that would give us 27, times negative 2 cubed, would give us negative 8 x cubed. If I multiply all these together, I will get negative 4320 x cubed. Now we've got to recognize that the a is the coefficient of my x squared, and the b is my coefficient of x cubed. So thus a equals 4860, and B equals negative 4320. Okay, good. Now, did we answer the question? Nope, not yet. Find the value of A divided by B. Okay, so A divided by B would be 4860 divided by negative 4320, and that would give us negative 9/8, and that is the answer. Good. Thank you, ladies and gents. That will be all for today on binomial expansion. I will see you later again.